Good morning, students. Today's topic Unit 3 Multivariable Calculus. In that, chain rule. Chain rule. Let Z be a function of two variables u and v, where u is a function of xy and g is also a function of xy. While substituting u's in this function f, then z will becomes in terms of xy. Then we will have dou z by dou x can be written as dou z upon dou u into dou u by dou x plus dou z by dou v into dou v by dou x. Dou z by dou y is dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou x. These two equations are known as chain rule. So here z is a function of uv and uv's are in terms of xy. Substituting these values in this, z is ultimately becomes in terms of xy. Z is a composite function. So these two equations are known as chain rule for the partial differentiation. So these are referred to as chain rule of the partial differentiation. Problem: if z is f of xy, where x is e power u cos v and y is e power u sin v, then show that y dou z by dou u plus x dou z by dou v is e power 2u dou z by dou y. Dou z by dou x whole square plus dou z by dou y whole square is e power minus 2 of dou z by dou u whole square plus dou z by dou v whole square. So using these equations and using a chain rule, we have to prove these conditions. For this solution, we have x and y values, given values. Now obtaining dou z by dou u using chain rule, formula is dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. Dou x by dou u is obtained by differentiating x partially with respect to u, keeping v as constant, cos v constant, e power u derivative as it is e power u. Dou y by dou u, which is obtained by differentiating y partially with respect to u, keeping v as constant. Sin v is treated as a silent, e power u derivative as it is e power u. But e power u sin v is y and e power u cos v is x. Replacing, we will have the value of dou z by dou u. Similarly, we can obtain the value of dou z by dou v. So it is the value of dou z by dou v. Now x into dou z by dou v is minus xy into dou z by dou x plus x square into dou z by dou y, which is obtained just by multiplying this equation with x. Now adding these two equations, so we will have y dou z by dou u plus x into dou z by dou v. Just adding those two terms and taking the common as dou z by dou y. But what is the value of cos square v plus sin square v? We will have cos square theta plus sin square theta is 1. So cos square v plus sin square v is also 1. So it is required one statement. Now to get another statement, we will have dou z by dou u, which is multiplied with e power minus u, and x is e power u cos v, and dou x by dou u value, dou x by dou v value, dou y by dou u value, dou y by dou v value, which are obtained by differentiating x and y partially with respect to u and v respectively. While differentiating partially with respect to u, keep v as constant. While differentiating partially with respect to v, keep u as constant. Now on squaring, we get dou z by dou v value also obtained. So let it be equation 3, and this will be multiplied with e power minus u, so that we will have e power minus u into dou z by dou v. On squaring, we will get e power minus 2u dou z by dou v whole square. So let it be equation number 4. On adding 3 and 4 equations and taking the common as e power minus 2u and then simplifying, so we will have e sin square v plus cos square v value is 1. This will gives the required second statement, hence proved. Another sum, if u is u of y minus z, z minus x minus y, prove that dou u by dou x plus dou u by dou y plus dou u by dou z is 0. Let R is y minus z, S is z minus x, and t is x minus y. Then u becomes a function of R S t. Now to compute the required partial derivatives of u with respect to x, y, z, we will use chain rule. Dou u by dou x. The formula for dou u by dou x is dou u by dou r into dou r by dou x plus dou u by dou s into dou s by dou x plus dou u by dou t into dou t by dou x. So since here u is a function of r s t, now using r s t variables, we have to split dou u by dou x like this by using chain rule. Now computing these partial derivatives dou r by dou x, dou s by dou x, and dou t by dou x. Substituting the values dou r by dou x, differentiating r partially with respect to x, keeping other variables treated as constant, that is yz are constant, y minus z derivative is 0. Similarly, dou s by dou x, z derivative 0, minus x derivative minus 1. Dou t by dou x, x derivative is 1 and minus y derivative is 0, so 1. On simplifying, minus dou u by dou s plus dou u by dou t. Let it be equation 1. Similarly, we can obtain dou u by dou y. So it is the value of dou u by dou y. Let it be equation number 2. Similarly, dou u by dou z is also obtained. Just we have to split the dou u by dou z by using chain rule, and we have to compute the required partial derivatives using the RST equations. Let it be equation 3. Now adding these three equations, that is 1, 2, 3, all terms are get cancelled, so we will have the result as 0. Hence proved. So simple. Just we have to name the functions RST, and we have to compute the required partial derivatives which are splitted by using chain rule. Just we have to add these three equations so that we will get 0 as result. Hence another sum, if u is u of y minus x by xy comma z minus x by xz, then show that x square dou u by dou x plus y square dou u by dou y plus z square dou u by dou z is 0. Solution, given u of r comma s. Here r is y minus x by xy and s is z minus x by zx. So r is y minus x by xy. We need the partial derivative of dou u by dou x, dou u by dou y, and dou u by dou z. To compute these partial derivatives, we need some derivative values. Those are dou r by dou x, dou r by dou y, and dou r by dou z. To get these partial derivatives with respect to x, y, z, just we have to simplify r. Y by xy is 1 by x, minus x by xy is minus 1 by y. Now differentiating r partially with respect to x, keep y as constant. 1 by x derivative is minus 1 by x square, minus 1 by y derivative 0. Dou r by dou y, 1 by x derivative 0 minus constant 1 by y derivative minus 1 by y square minus into minus plus 1 by y square. Dou r by dou z, differentiating r partially with respect to z, keeping xy as constant. Both the derivative becomes 0 because while differentiating partial with respect to z, we have to show the partiality, that is xy are treated as constant. And S is z minus x by xy. Now splitting the fraction, so we will have z by zx is 1 by x minus x by zx is 1 by z. Now which is differentiated partially with respect to x, y, z. So we will have the expressions like this. While differentiating partially with respect to one variable, other variable treated as constant. Now dou u by dou x can be splitted as dou u by dou r into dou r by dou x plus dou u by dou s into dou s by dou x. Substituting the above values and then simplifying or rewriting the terms, we will have the value of dou u by dou x. Similarly, x square, just multiplying on both sides with x square, we will have x square into dou u by dou x. Let it be equation 1. Similarly, dou u by dou y value, which is obtained by using a chain rule and substituting the above values, we will have 1 by y square into dou u by dou r. Just multiplying on both sides with y square, so that we will have y square into dou u by dou y is dou u by dou r. Let it be equation 2. Now adding these two equations, 1 and 2, 3. So 1, 2, 3. So we will have the value, all terms are get cancelled. The result is 0. So simple thing, just we have to define RS. RS are defined here. Compute the partial derivatives of RS with respect to XYZ respectively. We need these partial derivatives, and then the partial derivatives are multiplied with x square, y square, z square respectively. Dou u by dou x, just split the using chain rule and then multiply on both sides, we will get x square dou u by dou x. Similarly, dou u by dou y, which is multiplied with y square, we will get y square dou u by dou y. Let it be equation 2. And dou u by dou z, which is also splitted by using chain rule and substituting the above partial values, we will have dou u by dou z, which is multiplied on both sides with z square. Let it be equation number 3. Now just adding these three equations, all terms are get cancelled, which shows the required statement, hence proved. The statement is proved. Thank you. For any queries or doubts or any clarifications, please contact my contact number, mobile number, and this is my email address, SK ABDUL Shakir 786 at the rate gmail.com. Thank you.